This is another video in Unit 2 in Chemistry and Honors Chemistry. We're in the unit Numbers and Science, and this video is entitled Percent Error. It's just a short little video. As we've learned, all measurements contain some amount of error. And what percent error does is it's going to be able to see how accurate our measurement is compared to what we're going to call a true value. So the measurement that we take in a lab, or the results that we get in the lab, are going to be compared to a true value, and then we're going to calculate the percent error. The formula for doing this is the following. This is a formula you're going to have memorized. It won't be given to you. Percent error is equal to the difference between the experimental value and the true value, divided by the true value times 100. Sometimes people call true value the actual value. So that could be another word for a true value. That difference in the numerator, experimental minus true value, we want that to be a positive number. So you will take the absolute value of whatever the difference between the two happens to be. Well, let's first of all define what is an experimental value. The experimental value, as the name implies, is what you get in an experiment. It's your data. The true value is something that a textbook might give to you. It's a value that many different scientists have come up with, doing many different experiments, repeating it over and over again, having other people critique their data, having other people replicate their data, and then it winds up being called the accepted value or the true value. So let's do a practice problem. We've been talking about density in the lab during this unit because we can really do a lot with density to teach us everything we need to know about numbers and science. A student has measured the mass and a volume of an unknown substance and calculates the density to be 1.40 grams per milliliter. The true value, or the actual value, of the density is 1.30 grams per milliliter. What is the student's percent error? Well, first of all, of those two values, the experimental value is the 1.40, and then the actual or the true value is 1.30. So here is our percent error equation again. And so that numerator is nothing more than the difference between your value, your experimental value, and the true value. That's all it is. We want that to be a positive number, so really there should be absolute value brackets in the numerator. So we take the difference. Our value, our experimental value is 1.40, the true value is 1.30, and the difference between the two is 0.10. Notice I kept my sig figs correct in that calculation, 2 decimal places. Well, now to calculate the percent error, we're going to take that difference that we just calculated, 0.10, and we're going to divide it by the true value or the actual value. Sometimes people get confused. Should I divide it by my value? No, you divide it by the true value. In other words, you were off by 0.10. That doesn't sound too bad. But 0.10 out of what? 0.10 out of 1.30. So again, we've got our differences in our values, which turns out to be 0.10, divided by the true value, 1.30. To make it into a percent, you multiply by 100, and you have a percent error of 7.7%. Be ready to practice this a lot tomorrow. See you then.